Okay, on your homework, you had 5 to 17, okay? Here's 15 that had posed a couple questions in the past. You know, and sometimes we get a little bit confused if it's not exactly the way we're used to, but notice on this one, we had 0 on one side, 3m, which didn't have a denominator, but this was over 8, okay? But you can still use the same principle. Since there's only one fraction, 8 would be the common denominator. So if I multiply everything by 8, 0 times 8 is still 0, 3m times 8 is 24m, and then multiplying by 8 here simply cancels out that 8 in the denominator. So I distribute my negative, and I have 24m minus 3m plus 7, so this gives me a 21m plus 7, and at that point should be pretty easy to finish. Okay, subtract 7 and divide by 21. Okay, so there was number 15. Did you guys have any questions about any of the ones you had to finish? All right. By the way, would there be any domain restrictions on this one? Okay. So you're shaking your head no? Yeah, there would be none because there are no variables in my denominator. Okay? When you don't have variables in your denominator, then you're not going to have any restrictions on your domain, at least for the time being. Okay? All right. Now, just want to quickly review here. Remember, our basic process is look at all your fractions, get a common denominator, but we're not actually going to try to get everything to have that common denominator. We're just going to multiply it because that will then cancel out all the denominators. Like we did here, 8 canceled out the 8 and the 4. We ended up with no fractions after we did that. If you're still ending up with fractions after you multiply by the common denominator, then you're doing something incorrectly. Okay? So just wanted to review that. And today what we're going to actually spend some time doing is practicing a little bit more of this, and also giving you an opportunity to solve some problems where you end up with a number of these fractions. So let's take a quick look at page 300. I just want to take a quick look at the type of problem that you might run into in dealing with these. Okay? Obviously, some of these are just translation types of problems. And on page 300, problem number 1 is one type of problem like that, where we're just doing some translation work. So, let's see, page 300, problem number 1. Would someone read that nice and loud for us, please? Jacob?
1/4 of a number is 2 more than 1/5 of a number from the number.
1/4 of a number is 2 more than?
More
than 1/5. So we kind of have these, manufactured types of problems where, we're just talking about this random number. Okay. But let's talk about how we would approach this. What would be Obviously, in this case, x is going to be our number. Okay. But how would we go about writing an equation for this? Identify your equal sign. Where's our equal sign? Is. Alright? And we want to do that because there's going to be one half of our equation. There's going to be the other half of the equation. Okay? So let's translate this half. How would we translate that?
X over 4.
Good. 1/4 x or x over 4. Alright? X over 4 is how I would write it. Okay? And then 2 more than 1/5 of a number. How would we translate that? Two more than 1/5 of a number. Elizabeth?
2x over 5?
Close. I like the x over 5, but 2 more than would be,
Plus
there we go, plus 2. 2 more than 1/5 of a number. Okay? So here's an example where we've got our equation. 1/4 of a number is 2 more than 1/5 of a number. And now we can solve this using the strategy we've been talking about. Okay? So what would we multiply everything by in this case? Jacob?
20.
By 20. Good. And make sure that you are fair. Okay? So 20 times x over 4 would simplify to 5x. Good. 20 times x over 5 would simplify to 4x. And then 2 times 20 is 40. Okay. So at this point, we need to get all these variables on the same side. So we'd subtract the 4x, and actually that'll finish solving it for us. Okay? We get x equal to 40. And you can even double check that. 1/4 of 40 is 10. 1/5 of 40 is 8 plus 2 is 10. Okay? You can double check yourself there. Okay? So that's one of the ones that's a little more, manufactured here. But let's use, this will actually give us a good little review of the ratios as well. Let's take a look at number 4. Okay? Number 4 says the following. Okay? 3 numbers are in the ratio 3 to 5 to 6. Okay? 1/4 of their sum is 1.5 times more than the smallest number. Find the numbers. Okay? So this is one of those ratio ones. Okay? So how would we set this? How would we have to deal with this? If they're in the ratio 3 to 5 to 6, then how would we represent each of the numbers? Remember how we do that when we're talking about ratios like this?
We do 3x, 5x is 6x.
There we go. Remember, x is like how many units per part. So this would be 3x, 5x, and 6x. Does that ring a bell now? Okay. And we'd be letting x equal the units per part of the ratio. Remember, this is in lowest terms. 3, 5, and 6 have that ratio, but if I added those, 14 is not 1.5 times as big as 3. Okay? The sum of those, 1/4, or their sum would be 14. 1/4 of 14 is 1/4 of 14 would be 3.5. Okay? Well, 3.5 is not 1.5 times as big as 3. Okay, so we need to figure out what the actual numbers are. Okay, so it says 1/4 of their sum. What's the sum of these? Hmm? 14x. And 1/4 of that would be 14x over 4, right? Okay? And that is, there's my equal sign, 1.5 times the smallest number. So that's 3x. Okay? So now, what I would do is I'd simplify both sides first. 7x over 2 is going to equal, this is 3 halves. 3 halves times 3x would make 9x over 2. Okay? And hang on, that's not
That's 4.5.
what?
3 times 1.5 is 4.5.
Yes. Which is the same as 9 halves. The problem is, so we're going to get x equals 0. Which we don't want that. Because then it would just be all the 3 numbers are 0, 0s, and 0. Hang on, what am I missing here?
Oh.
One-fourth of their sum is 1.5 times more. Wait, is it 1.5 times or is it just 1.5 more?
This is 1.5 more.
Ah.
This would be additional.
Yes. I was going to say, that's not going to work. 1.5, I inserted a word that shouldn't have been there. There we go. That's a lot better. Okay. Alright. So that should be a plus 1.5 more than the smaller number. So that's 3 halves plus 3x. Now, since we're dealing with halves, it probably wouldn't be that big of a deal if we just left the fractions in, okay? Or if you want to, you can multiply everything by 2, and that would get rid of all the fractions, okay? 7x equals 3 plus 6x. And then, of course, you subtract the 6x and you get x equal to 3, okay? Now, that does not give us the numbers, but that does give us how many units are in each part of our ratio. So this would be 9, 15, and 18. Okay, so those would be our three numbers. And if you try it, okay, this would be 33 plus 9 is 42. If you took a quarter of that, that would be 10 and a half. Well, 9 plus 1 and a half would be 10 and a half. Okay? So, you can work those out. And obviously there are infinite possibilities as far as what kinds of problems we could cover. Okay, so, does anyone have any questions?
On this problem or?
On, yeah.
Oh, okay.
Or do you have questions on other parts?
No. I was just wondering about number 16.
Oh.
Because that one, this one, I kind of doubt we'll be doing this one.
No, you won't be, but I could take a look at that if you'd like to.
Okay.
With you.
Mm.
All right. Now, what I'd like you to do here, gonna have you work on, page 299 is where actually page 300 is where number 19 starts, so I'll change that to 300. Okay, written exercises numbers 19 to 29. Now I'd like you to try some of the problems here. I'd like you to do we'll go 5 through 11, the odds here, on the word problems. Okay? So, yes, you may.
Yes.
19 to 29, the odds are all.
I'm sorry, what?
Is it all 19 to 29?
That was odds. Although if you finish and you have time left, go ahead and go back and try the evens too.
Do you want to do your
Okay. And tomorrow I'm going to have a quiz over 7-1 to 7-3. Okay? 7-1 to 7-3 quiz over ratios, proportions, and a little bit of problem